We're continuing to classify lines as either parallel, perpendicular, or neither. In the previous video, we were given two lines that pass through two given points, and we can find the slope of those two lines using our slope formula and compare the slopes to find out whether they are indeed parallel, perpendicular, or neither. Well, in this section, we're going to be given the equations of two lines instead of 2 points that are on each line. So let's look at the first one. Let's look at a few examples. Line 1 is described by the equation 2x minus 3y equals 5. And line 2 is given by the equation 4x minus 6y equals 0. Now we should know by now, we should recognize that these two lines are in standard form. And we know that when we have a line in standard form, it's in the form ax plus by equals c, where the slope of this line equals minus a over b. All right, we proved that earlier. So we can use this information to pick out the slopes of these two lines, and then we can compare them. So the slope of line 1, so m sub 1, is going to be minus a divided by b, which is a minus 3. Remember, b takes on the operator. We cancel the two negative signs, gives us a positive 2 over 3. So this is the slope of line 1. Now we need the slope of line 2, so m sub 2. We find that by finding minus a over b, so we have minus 4 over minus 6. These two negatives cancel. 4 over 6 simplifies to a positive 2 over 3. And we can see that the slopes of the two lines are identical, so that means the two lines are what we call parallel. That means they go forever in each direction, but they never intersect, they never touch. All right, we're using what we know to find the slopes of two lines and then compare them to classify them. So let's do a few more. Let's say line 2 is described by the equation y equals minus 7x plus 3. And line 2 is given by the equation y equals 7x minus 3. Okay, so these two lines, we should recognize they're in slope-intercept form. Slope-intercept form is given in the form y equals mx plus b, where m equals our slope. So the coefficient of x is our slope. And we can, slope-intercept form, this is the reason why it's so useful, is because we can easily pick off our slopes right here. We have a minus 7 and a positive 7. So they're indeed not equal, they're not identical, because one's negative and one's positive, so they can't be parallel. For them to be perpendicular, they need to be negative reciprocals of each other. So one needs to be negative and one needs to be positive, which is the case here, but they're actually just both the same number. They're not reciprocals. This is a negative 7. If this was a positive 1 over 7, then it'd be negative reciprocals of each other. And a good way to check this is if we multiply the two slopes together, we should get negative 1, and that's not the case here. So these two lines are indeed neither parallel nor perpendicular. Okay, let's look at another one. Let's say we have line 1 is given by the equation y minus 1 equals minus 1/2 times x plus 4. And line 2 is given by the equation y plus 1/2 equals 2x. Okay, so we should recognize these two lines as being in point-slope form. Point-slope form is given by the equation y minus y naught equals m times x minus x naught. And in point-slope form, our slope is just the m term. M is our slope, so we can easily pick that out. In these two equations, we have a slope of minus 1/2 and a slope of 2. 2 can also be written as 2 over 1, So in which I actually like to write the fraction form when I'm comparing slopes, because you can see more clearly if they're reciprocals of one another, which indeed this is the case. 1/2 is the reciprocal of 2 over 1. One's negative and one's positive, which means these two slopes are negative reciprocals of one another, which supposes that they're perpendicular. But a good way to check if they're perpendicular, which we always really want to do, is multiplying them together. Minus 1/2 times 2 over 1, and this should give us a -1. So let's see, minus times a positive gives us a negative. 1 times 2 is 2, 2 times 1 is 2, and that results in a -1, which checks out, and these two lines are indeed perpendicular. Perpendicular. So the two slopes have are negative reciprocals of one another, and that tells us that they are perpendicular to one another, and we can check that by multiplying them together to get -1, and if so, that checks out. Let's do one more. Let's look at line 1 is given by the equation minus x minus 2y equals 21, and line 2 is given by the equation y equals minus x over 2 minus 9. Okay, here we have a mixed bag. This equation of line 1 is, well, looks pretty close to standard form, except for this is just a negative, but we can deal with that in a second. And this equation is in slope-intercept form. So let's go ahead and rewrite these two so we can actually make our slopes stand out. So let's rewrite line 1. We can divide through by -1. Remember, the coefficient of x, which is also called the leading coefficient, needs to be non-negative. So these two signs cancel, these two negatives cancel, so we have x plus 2y equals a -21. And then over here, let's go ahead and rewrite this. We have y equals minus, we can separate x out of the numerator, so we have minus 1/2 x minus 9. And now we have a slope here of minus 1/2, and this is in standard form now, and we know the slope of standard form is the slope equals minus a over b, so this is a 1, so we have a minus 1 over 2. And indeed, these two slopes of these two lines are identical. They're both minus 1/2, which means the two lines are parallel. They will travel in both directions infinitely, and they will never touch. They'll never intersect. So we're continuing to classify lines as either parallel, perpendicular, or neither. And we're simply just using what we know about different forms of linear equations, and what we know about the way their slopes are identified. We can pick out the slopes to compare them, and if the slopes are identical, then that means their respective lines are parallel. If one slope is a negative reciprocal of the other slope, that means the respective lines are perpendicular. That means they'll intersect, forming a perfect 90-degree angle. And if they're neither equal nor perpendicular, they're neither parallel or perpendicular, that means they're just neither. So this is very useful. Be sure to go over this a few times and get a really good handle on it, and I'll see you soon.